Good afternoon, students, and welcome to Q&I summer course. I am Sunit Kumar, your mathematics teacher. And so first of all, students, let me, you know, introduce myself. So I'm Sunit Kumar, your mathematics teacher. And we have been doing the chapter real numbers. So in the last class, what we learned was plotting real numbers, irrational numbers on the number line. So we were doing some questions. We had also did what we did in the previous class was we proved whether a number is irrational or not, right? So we proved it for root 2, we proved it for root 3. So now we'll do, today in the class, we'll do it for root 5 also. And let us start the class and let us start practicing the questions based on that. So as I said, we are doing real numbers right now. And the prerequisite for today's class is to understand what irrational numbers are and what rational numbers are. And in today's class, we'll prove if a number is irrational. We had done some part in the previous class as well. So I'll quickly revise this formula which we did in the last class is let P be a prime number. And if P divides A square, then P divides A as well, where A is a positive integer. So let's say we have A square and this is divisible by some prime number P. We can write this as A into A divided by P. Now, because prime number has only two factors, one in the number itself. So that's why a will, if it is A square is divisible by P, then A will also be independently divisible by P, right? Because you cannot further factorize P. So it will be directly A will be divisible by P. Is it clear? Raghavi, Ragul, Devi Maya and Jovin. I hope
Yes,
this
sir.
is clear. Yeah.
Yes, sir.
Now let us quickly prove that root 5 is irrational. So, I'll do it together with you. So what you need to do is you can tell me the steps one by one. Okay. So what is the first step? How do you prove root 5 to be irrational? Step number
Let
one,
us
Assume
assume
root
root
5 was
5 is
rational.
rational
one,
number.
one by one. Okay. So, yes. So let us assume. So we'll assume that root 5 is a rational number, right? So we prove by, contradiction method. So if we have to prove root 5 to be irrational, let us assume root 5 to be rational, right? So we have assumed root 5 to be rational. Second step. So we will write root 5 as r by s, where we cut this common term, and then we have a by b, where a and b are co-primes, right? So there is no factor in common between a and b. Correct? Okay. After this, what we are going to do?
B root 5 is equal to A.
Okay, so we'll take b on the other side. We'll have b root 5 is equal to a. And then so I'll ask one by one.
Square on
Devi,
both.
okay, so we'll square on both the sides. So we will have 5b square is equal to a square. Squaring on both sides. Okay. Now, once you have got 5b square is equal to a square, that means b square is equal to a square by 5. So since b is an integer, b square will also be an integer, and a square by 5 is also an integer. So that means a square is divisible by 5. So this means a square is divisible by 5.
Sir, if A
And
square divided with
Rahul, I could not hear you completely. Can you repeat your?
If a square divides 5, a also divides 5. The next step is
Yeah. A square is divisible by 5. This means since 5 is a prime number, a is also divisible by 5. Okay. So here we are going to stop, and now since a is divisible by 5, we can write a as a equal to 5 times c, because a is divisible by 5 means 5 is a factor of a, so a can be written 5 times c. So let's say this is your first equation and this is your second equation. We substitute equation 2 in the value of a from 2 in 1. So what we are going to get is 5b square is equal to 5c whole square. So that is 5b square is 25c square, or b square is c square by 5. Now, since b is an integer, right? Sorry. C square is equal to b square by 5. Now c is an integer, so b square by 5 is also an integer. That means b square is divisible by 5. B square is divisible by 5. So since b square is divisible by 5, b is also divisible by 5. Right? Now b is also divisible by 5, right? So since, see, a is divisible by 5 and b is also divisible by 5, this means 5 is a common factor between a and b. But what did we assume here, that a and b are co-primes, right? Right. So here we have a contradiction. So there is a contradiction here, right? And this is because, so there is a contradiction as our assumption is wrong. So since our assumption is wrong, students, okay, so that means root 5 is irrational. Is it clear? Have you understood this?
yes, sir.
Okay. So if you want to note it down, please note this down quickly. Once you have noted this down, I can move to the next. Okay. So I'll remove this, students. So students, I have the students who don't have the login ID and password. How many students do not have login ID and password for the platform practice? Those who do not have login ID and password, please click on this link and fill in this form. Okay. So these are basic details which you have to fill in. Once you fill in the form, we will create your login ID and password. And tomorrow at 11:30 a.m. in the morning, we have a proficiency diagnostic test. Now this test, what it does is that it calibrates the platform as per your understanding and your level, so that the question which comes when you go to practice there will be as per your understanding, current understanding level. Okay. So please take the test, because that is the first step towards practicing on the platform. Right. So tomorrow 11:30 a.m. you have to join in with the same login ID and password which we are going to create it for you, and we'll share it with you. Okay. Even if we are not sharing it, please join the link tomorrow for diagnostic test if you have not taken it. We'll create it at that instant only. So let's move ahead, students. Now we have to prove 3 plus 2 root 5 is irrational. Okay. So again, in these questions, we prove it by contradiction only. So let 3 plus 2 root 5 is rational. Okay. So once you have assumed it to be rational, now this implies 3 plus 2 root 5 is equal to P by Q because it is rational. Now what we are going to do, we know that root 5 is irrational. So we'll separate it on one side and rest other things will move on the other side. So 3 if we take on the other side, we'll have 2 root 5 is P by Q minus 3, which can be written as P minus 3Q over Q. And then root 5 can be written as P minus 3Q over 2Q. Now since P and Q are integers, P minus 3Q will also be an integer and similarly 2Q will also be an integer. So ratio of integers is rational numbers. So your RHS is rational and your LHS is irrational. You cannot equate an irrational number with a rational number, since rational number cannot be equated to an irrational number. Hence, there is a contradiction which has arisen, has arisen because of our wrong assumption, right? That 3 plus 2 root 5 is rational. So that means 3 plus 2 root 5 is irrational and not rational. Is it clear? Note this down quickly, students.
Sir,
Yes, Raghavi.
sir, in these type of questions, if they're asking in exam, first we should we have to prove root 5 is irrational, then we should do all these steps, and then we should prove 3 plus 2 root 5 is irrational number.
No, until unless it has been asked to do that, right? So if the question is simply prove that 3 plus 2 root 5 is irrational, you will assume that root 5 is irrational and do it only this much which I have done. If they say that prove root 5 is irrational and hence prove that 3 plus 2 root 5 is irrational, then you will do both of the proofs.
Okay, sir.
And in exams generally, because in NCERT they have not specifically mentioned this, but in exam they specifically mention this also, that prove that 3 plus 2 root 5 is irrational, assuming that root 5 is irrational. Okay.
Okay, sir.
Harsh, which school are you from?
Keeping, sir. Keeping.
Oh, I'm talking about Harsh. Harsh, can you let me know about your school? Because you have not joined with a link. You have not joined with the name of the school. You can write it in the chat also. Okay, students, let's move to the next question. Now, prove that the following are irrational. So first one, 1 by root 2. How will you approach this question? How will you prove that 1 by root 2 is irrational? Can someone tell me? No one. What should be my first step to prove 1 by root 2 to be irrational? Okay, let me do it for you. Yeah, Harsh, yeah, we'll equate to P by Q. So we have two students who have not joined with the name Harsh and Helvi. Can you please let me know your school's name? Okay, so see 1 by root 2 AVJC. What's the full form of AVJC? Okay, Agarwal Vidyalaya, Chennai. Okay, okay. Thank you. So, in these questions, there are two ways of doing it, right? So one method which Hars is saying that we equate it to P by Q, then cross multiply. We can do that. But then, see, there is a challenge there. If you do this 1 by root 2 is equal to P by Q, let's say 1 by root 2 is of the form P by Q, then what you do when you cross multiply, you will have root 2 is equal to Q by P. Now, for a rational number, we know that the denominator should not be equal to 0. So when I say that 1 by root 2, if it is rational, P by Q, it can be represented in the form P by Q, where P and Q are integers and Q not equal to 0. But when you take a reciprocal, when you do a cross multiplication, it will become Q by P. Now here we don't have a condition for P. In the initial case, we only had a condition for Q, that Q is not equal to 0. But P also should not be equal to 0 if I am cross multiplying it, right? So that's why what we do is, I'll tell you how to approach this question. 1 by root 2 can be written as I multiply both numerator and denominator by root 2. So this is nothing but root 2 by 2. 1 by root 2 is same as root 2 by 2. Once you cancel this, you will get 1 by root 2. So now let 1 by root 2 is rational. Let us assume that 1 by root 2 is rational. That means root 2 by 2 is rational. Now since root 2 by 2 is rational, you can write root 2 by 2 as P by Q. Now take 2 on the other side. You will have root 2 is equal to 2P by Q. Now see, left side, this is an irrational number and 2P by Q is a rational number, right? Why? Because 2P is an integer, Q is an integer, and Q is not equal to 0, right? Because we have assumed it to be rational. We have said that P and Q belongs to Z and Q is not equal to 0. So we cannot equate an irrational number with a rational number, right? Now, since we cannot equate a rational number to an irrational number, right? So our assumption is wrong, right? Hence, 1 by root 2 is irrational. Is it clear, students? Harsh, could you understand why we are not writing it as P by Q and we are not taking a cross multiplication? Because when I write 1 by root 2 as P by Q, I'll say that Q is not equal to 0. But when I do cross multiplication, root 2 will become Q by P. But I don't have a separately, I have not mentioned that P is also not equal to 0. Right? So that would not be a correct way of doing it. People do that and many people do it that way. But I personally feel that, you should be doing it this way. Okay. In exams, you may get marks in that also. There's no issues in that as well. But then you should always know some nuances that why we should not write it that way. Raghavi, Raghul, and others, Jovin, Devi Maya, is it clear to everyone? Have you understood this?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, great. Let's move ahead then. So whenever you have students, whenever you have this, square root terms in denominator, you always do it this way. There will be a question later on which you will see. Prove 1 by root 7 to be, irrational. So here also you will write it as root 7 by 7 and then do it. It will become easier for you. Clear? Shall we do the second one, students? Second one is simple. You don't have to do all of this because we have 7 root 5. So what we do, we separate out the square root term and then take other terms on the other on other side of the equation, and then we prove it. Okay. So we have to prove 7 root 5 to be irrational. So let us assume 7 root 5 is rational. So when you assume 7 root 5 to be rational, you can write it in the form P by Q, where Q is not equal to 0. And then root 5 will become P by 7Q. Now we know that P and 7Q both are integers. P and Q are integers, and that's why 7Q will also be an integer. So root 5, the LHS, since LHS is irrational and RHS is rational, and we cannot equate the rational number to an irrational number. So hence our assumption is wrong. So this value 7 root 5 is irrational. Is this clear, students? So these are similar questions. So 7 root 5, is it clear to everyone?
Yes, sir.
Yes, sir. Clear.
Okay, good. So you can quickly note this down and then I'll move to the next one. The next one is we have to prove 6 plus root 2. You have to prove 6 plus root 2 to be irrational. So again, let us assume that 6 plus root 2 is rational. So in that case, you can write 6 plus root 2 is equal to P by Q, where P and Q are integers and Q is not equal to 0. So I'll isolate root 2 on one side, which is irrational. So I'll write root 2 is equal to P by Q minus 6, or root 2 is P minus 6Q over Q. Now P minus 6Q over Q is rational and root 2 is irrational. So since LHS is irrational and RHS is rational, we cannot equate a rational number to an irrational number. Hence our assumption is wrong and 6 plus root 2 is irrational. Is it clear? Is this clear, students?
Yes, sir.
Hers, can you repeat your question? So you are writing, sir, but we assumed in first that root is rational. Yeah, we assumed that 6 plus root 2 is rational. This is what we assumed. And if we keep proving that further and further, so we will get root is rational, which we assumed first. No, how do you get that? See, 6 plus root 2, I have assumed it to be rational. But root 2 is equal to P by Q minus 6. That is P minus 6Q by Q. Now your RHS is rational, but we already know that root 2 is irrational. Right? In these questions, we already have got this information that root 2, root 3, root 5 or square root of any prime number is irrational. From there we start this proof. Otherwise, we'll first prove root 2 to be irrational, which we have done in previous classes. Okay. So from there, we are taking this because we have already proved that root 2, root 3 and root 5 is irrational. That's why we are using that concept, because LHS becomes irrational, root 2, and RHS is rational. We cannot equate a rational and irrational together. And that's why we say that our assumption is wrong. And hence this whole thing 6 plus root 2 is irrational. We had assumed it to be rational initially. Because of this contradiction, we say that our assumption is wrong. The contradiction is that you cannot equate an irrational number to a rational number. Is it clear, Harsh? So students who have joined today, I think there are many students who have joined today. So everyone from Agrawal Vidyalaya only? Okay. So, what I'll do, I'll quickly tell you how to prove this root 2 to be irrational so that, you all are in sync with what we have been doing in the class. Okay. Okay. So before I attempt this question, let me prove that how root 2 is irrational. In fact, at the start of the class also we did it for root 5. So let me do it for root 2 here. So let's say we had to prove root 2 to be irrational. So in this, what we do? So let us assume that root 2 is rational. So we always prove this by negation. So we assume that whatever we had to prove that root 2 is irrational. So we'll assume that let it be rational, right? So let root 2 is rational, opposite of what we had to prove. Now, after proving, what we'll get is that there comes a contradiction. So once there is a contradiction, then we say that this contradiction is because we have assumed it wrong initially, and that's why root 2 is not rational, but it is irrational. That's the whole idea of this kind of proofs. And one question definitely comes to prove this. Either it will be root 2 or root 3 or root 5 in your board exams. So let us assume that root 2 is rational. Then we can write root 2 as ratio of two integers r by s, where after cancelling the common terms, let's say in simplest form, this is a by b, where a and b are co-primes. Okay. If we have cancelled out the common factor between r and s, there is no other common factor between a and b, then we say that a and b are co-primes. Right? Good that you are in 5th chapter. I just wanted to have a continuation of what we had to prove. So I'll just quickly do this. Even if you know it, just it will be a revision. So root 2 can be written as a by b. Then what we do is that we take b on the other side. B root 2 is equal to a. We take a square here. So this will become 2b square is equal to a square, or we can write it as b square is equal to a square by 2. Now, since b is an integer, b square will also be an integer. So right hand side also needs to be an integer. A square by 2, for it to be integer, a square should be divisible by 2. So that means a square is divisible by 2. Now since a square is divisible by 2, a is also divisible by 2. Right? Why? Because for any prime number, if a square is divisible by a prime number p, a will also be divisible by this prime number p. This we had already seen. This is a theorem which is there, and we are using that theorem directly here. So when a square is divisible by some prime number, a will also be divisible by that prime number. So we are using that theorem. So a is also divisible by 2. Now, if a is divisible by 2, we can write a is equal to 2c, means it will be 2 is a factor. If a is divisible by 2, then 2 is a factor of a. We can write a equal to 2 times c. So we have this first equation and second equation. Now we put the value of a equal to 2c in this equation. So you will get 2b square is equal to 4c square, or b square is equal to, so we have 2b square is equal to 4c square, right? Now we will have b square is equal to 2c square, or c square is equal to b square by 2. Now c again is an integer. So c square will also be an integer. That means b square is divisible by 2. Right? So b square is divisible by 2. This implies that b is also divisible by 2. So that means, see, a is divisible by 2 in b is also divisible by 2. Means a and b has a common factor 2. But what did we assume here? That a and b are co-primes. That means they have no common factor between them. But after proving, means while proving, we came across at a point where a and b, we found that there is a common factor 2 there, right? So this is a contradiction, right? This is a contradiction, and this contradiction has arisen because of our wrong assumption, right? So this is a contradiction because of wrong assumption. This implies root 2 is irrational. Is it clear? Yes, Hers. See, co-prime numbers are those numbers. So co-prime are those numbers which do not have any other common factor other than 1. It can be prime numbers, it can be composite numbers. I'll give you an example. 4 and 9 are co-primes, right? So since there is no common factor between 4 and 9 other than 1. That's why we say that 4 and 9 are co-prime numbers. So co-primes can be any two numbers which has no factors in common other than 1. And integers are basically, you know, positive whole number, negative whole number, 0. All of this together are called integers. Is it clear? Yes, 6 and 3 are integers and not co-primes, because there are factors which are common. 3 is also common there between 6 and 3. And 6 and 5 are integers as well as co-primes, because there is no factor in common. There is only one which is common factor between 6 and 5, and they are integers as well. Correct. Okay. Let's proceed, students. There is one important question which I wanted to do today. Yeah, this one. So how do you prove this kind of question where you have two square roots? So prove that root 2 plus root 5 is irrational. Can someone tell me how to approach this question? So you just need to tell me, how do you approach this question when you have root 2 plus root 5 as irrational? Harsh, you can, unmute and tell me as well, because typing takes a lot of time. Yes, you are correct. So let us do that. Okay. So in these kind of questions, what we do, students, is that first let us assume root 2 plus root 5 is rational. Now, if it is rational, we'll write root 2 plus root 5 is equal to P by Q, right? So what we can do is we'll take one of these roots, because there are two roots. We'll take one of the roots on the other side. So we will have root 2 is equal to P by Q minus of root 5. After this, what we are going to do, we will square on both sides. So when we square on both sides, we have root 2 square is equal to P by Q minus root 5 whole square. So this is 2 is equal to P square by Q square plus 5 minus 2P root 5 by Q. Okay. Now take all of this on the other side, right? Or you bring 2 on this side and others on left side. So we'll have 2P root 5 over Q is equal to P square over Q square plus 5 minus 2. I have taken 2 on this side and this one on left side. So we will have 2P root 5 over Q is equal to P square by Q square plus 3. So now this can be written as P square plus 3Q square over Q square. So root 5 is equal to P square plus 3Q square over Q square into Q by 2P. Right, I have taken Q on the right side and 2P also on the right side. So division goes into multiplication and multiplication comes to division. Now we can cancel this 1Q here. So we will have root 5 is equal to P square plus 3Q square divided by 2PQ. Now you can see this RHS here, right? This quantity P square plus 3Q square by 2PQ. This is a rational number, right? Because ratio of integers are rational. But LHS is an irrational number. You cannot equate an irrational to a rational number. And that's why we say that our assumption was wrong. And hence root 2 plus root 5 is not rational. It is irrational. Is this clear, students? Is this clear to everyone? Raghavi and Ragul, is it clear? Alan, Devi Maya?
Yes, sir.
Yes, sir.
Yes, sir. Clear.
Okay. So this is an important question because it is not there in your NCERT, but these kind of questions come, right? So you should always try doing these questions where if you have two square root terms, take one square root term on the other side and then solve it. And eventually you will get a square root term separated on one side and other terms on the right side. So right side will become your rational number and left side is irrational, which is a contradiction. And that's why we say that our assumption is wrong. Okay. So students, I'll quickly, there are few announcements to make. Let me just quickly send you a link also. So there is a link which I am pasting here on the chat. So what you need to do is, this is a form, Google form basically, Teams form, where you have to fill in your details so that we can create your login ID and password on our platform, so that you can start practicing on the platform. Once I have delivered the lecture, I'll tell you the topic from which you have to practice and you can practice there. Today at 6 p.m. we'll have a practice session for 1 hour where you can log in on the platform. Students who already have your login ID and password, please keep it handy. When you join the link at 6 p.m., you just need to log in on the platform and then start doing the question. And if you have some doubt, you can ask us. We will be there in the class, respective classes. Okay. So whosoever teacher is there, he or she will tell you which chapter we are practicing and you can practice it on the platform. I'll quickly give you a glimpse of the platform as well, and for students who have joined for the first day. So when you log in on the platform, this is how the dashboard will look like, and you have to go on the practice and custom practice, right? Just a sec. Yeah, once you log in, students, you go on assessment, practice and custom practice. So you can see all the topics here, chapters here. So since we are doing the first chapter, that is real number, you will view topics here. And these are the topics. So we had done few topics. Now, you can do this, determine the nature of decimal expansion using prime factors. So this topic, you can practice it today as homework. So today in the evening when we meet, we'll do practice from this particular section. Okay. And students, tomorrow there is a session basically for diagnostic test. So students who have not taken the diagnostic test yet, please fill in this detail in the form. We'll create your login ID and password. You can take the test tomorrow. So that diagnostic test is basically to benchmark and to calibrate the AI based platform which understands. So no, not website link. This is the form which I'm saying. This link you have to fill in the details so that we can create your login ID and password. So once you take that test, the platform will is able to understand your strength, weaknesses, opportunity, and hurdle areas, and accordingly, you will be guided by us to cover that learning gap if there is some learning gap there. So every topic which we teach in class, you can go and practice on the platform. Okay. So thank you, students. Thanks for joining in. We will meet again next week now. So today in the evening, we'll meet for the practice, and then if you are taking the diagnostic test tomorrow, we'll meet then also. For classes, we'll again meet on Monday at 11:30 a.m. Thanks for joining. Thank you and take care. Bye. Take care. For the website is qanditoday.com.
Sir, can you type the website on the chat?
Yeah, I'll do that. So basically you will be able to access only when your login ID is created. So once your login ID is created, we'll help you. Right. So I've shared the link, right? So we'll guide you tomorrow in the morning where you can, where you can join the link at 11:30 in the morning. Yes, you can take all the chapters for practice, whatever you have, done in school. Okay. The customer support team will call you and give you all the details of login ID and password. Okay. If you have filled this form, they'll give you a call. So you just need to fill this form first. Okay. Next class is on Monday at 11:30 a.m. But today in the evening, 6 p.m., we have a practice session. But since you do not have your login IDs and password, you don't need to come today in the evening. But tomorrow, you can come for the diagnostic test at 11:30 a.m. We'll share the link with you. Okay. Thank you, students. Bye and take care.